Hello world, welcome to a Teapot Tech Talk. My name is Michael and today we're going to be doing things a little different. Instead of our usual podcast format with Sebastian, today we're going to try to do a screencast with just me. So in the words of Monty Python, let's get on with it. Today's topic is based on a talk I gave at our team meeting, which is why are JavaScript developers using Rust tools? So a common trend in software is to write tools we as developers use to build our application in the same language we use to build our application. For example, pip, a Python tool, is written in Python, Composer is written in PHP, and Maven is written in Java. JavaScript is not an exception to this rule, but some properties of JavaScript make this, shall we say, suboptimal. What are these properties? Let's take a look. So, JavaScript is a lightweight interpreted language that's mostly known as that thing that makes websites interactive. But let's be honest, it's not limited to browsers. It can be used on not browsers too. Think Node.js or Apache CouchDB. But its roots as a scripting language are still very visible. For example, it's still single-threaded. So why is this a problem to build our build tools with it? Well, honestly, it's kind of slow, especially when you compare it to native applications on console. It doesn't take advantages of stuff like multi-threading. And, those are kind of big deals when we want to focus on speed. I like to think that a bunch of JavaScript developers got together in a dark room one day, and between tequila shots, one of the devs asked a very important question. He said, "Hey guys, what if, hear me out, what if we didn't write the tools that build our JavaScript in JavaScript?" Pretty controversial idea if you think about it. But then, they did that. So let's be honest, you don't have to use the language you're using to build your applications to write the tools to build your application. You can write them in any languages. You can write them in Go or in C++ or in Rust. It doesn't actually matter. One thing I have to mention is, as long as it compiles to a native format, it will be faster than JavaScript. So I like Rust, so let's talk about Rust. Sorry, wrong Rust. That's the right Rust. So Rust is a multi-paradigm, general-purpose programming language developed for performance and safety. They really love the word safety, like safe concurrency, memory safety. They really love that word. It has all these nice properties, but the one I want to talk about most is that it is almost as fast as C++. And that's pretty much what we're interested in, speed. We will talk about why speed is important a little later on, but for now, let's talk about some of the not so JavaScript tools. First, we have ESBuild. And ESBuild is written in Go, not Rust, but I wanted to highlight it here because they have this incredible graphic I wanted to share, right? This one right here. Let's run this. That's a pretty visual, right? They literally saying, this is how long in real time you're going to have to wait if you're not using ESBuild. That's pretty impressive. But let's go back. Parcel.js is worth taking a look at because it's pretty good. If you have the time, take a good look at it. But that's not what I'm going to focus on today. Today I want to focus on SWC, the Speedy Web Compiler. Okay. The Speedy Web Compiler is a sort of like a framework for building developer tools. They have all these claims that they are 20 times faster than Babel on single cores or 70 times on 4 cores. But more importantly, Next.js uses SWC. Vercel introduced their Rust compiler in version 12, I believe, and they made the bold claim that it had 3x faster refreshes locally and 5x faster production builds. Those are really bold claims. If only there was some way to test those claims. Let's test those claims. So, I created the same project in Next 11 and Next 12. The two are identical except for the compilers. The one on the left, Next 11, uses Webpack, while the one on the right, Next 12, uses the new Rust compiler based on SWC. They both have the same absurd number of components, and we're going to see how long each build takes. Let's start 11. Here we go. Now, there we go. Now, we're deleting the build directory so that they don't build from cache. They have to build from scratch. Also, when doing comparison, it's kind of important to start them close to each other, right? You don't want to delay the other too much, as they will have like a head start, and then it really won't be a fair comparison. Yeah. I might be forgetting something. Right. Let's start next 12. God, I cannot believe I forgot that. How could I? Oh, right. Started. Okay. I think this is the point where we'd have elevator music. I think I'll add elevator music in post-production, you know? That was pretty fast, right? You know what? Let's try that again to see if it wasn't a fluke. Nope, that is still pretty fast. Maybe one more for good luck. You can tell that I'm enjoying myself a little too much, right? Yeah, so it's pretty obvious that the Rust compiler is way faster than Webpack. Honestly, this is not a 5x improvement in speed. 101 to 13 seconds, that's almost an 8x improvement. That, my friends, is a huge difference. It's a very big difference. I mean, but you know, it's impressive and all, but why should anyone care? I mean, John, who's sitting on his couch browsing your site, will never know you used a Rust compiler. It doesn't change the end user's experience, only the developer experience. So, for example, why should management care? Well, if having sane developers is not important to you, I have a better reason. Time and money. Slow builds are more expensive than fast builds. Imagine you have 20 developers making 20 branches, and each time they commit, the previous build runs. Either you're going to be waiting for a while for builds to finish, or paying more in build minutes on your CI. Either way, you are losing time and money. Either way, slow builds cost more in time and money, or both. And that, my friends, is why JavaScript developers are using Rusty tools. I'll see you guys on the next screencast if we do it. Until then, happy coding.